This is part 3 for page 277, the chapter 5 test. So again, tomorrow your student will be experiencing that chapter 5 test, and these are similar problems to it. So here's some examples. Number 22, an 8-foot flagpole casts a shadow that is 6 feet long, and at the same time a nearby tree casts a shadow that's 21 feet long. So we want to know how tall is the tree. So let's draw a picture of what's going on here. Here we've got the flagpole, and it casts a shadow. So there's our flag, and the flagpole, it says, is 8 feet. 8 feet, okay, and the shadow is right here. So the sun must be over here somewhere, and it's casting this shadow. Rays are coming down, and the shadow gets cast, and the shadow is 6 feet long, so it's a little bit shorter than that flagpole. So let's take off a little bit of that. So we've got 6 feet right here, and then we've got this tree. So we'll make the tree a little bit taller. Let's start up here, and I know it's taller because notice that the shadow that it casts is 21 feet, longer than the 6-foot shadow of the flagpole. So here's our tree, and the sun again is the rays are shining and it's causing that shadow, and we don't know the height of the tree. So let's use h. That's what we want to find. So what we have here basically are two triangles. So if we go ahead and draw a line from here to here, we have a triangle. Same thing over here. I could draw a line, and I've got two triangles. Hopefully your triangle looks a little better than my curvy one there. But anyhow, we look at this, and we've got two similar triangles. In similar triangles, we can use proportions to solve. So let's take a look at this. So the way I set up proportions is I like to set them up so that I have the same units in the same spot. So for instance, I've got the height of the object. So height of object over shadow. So that's the way I'm going to set up my proportion. Each ratio is going to have that. And so I can do the other one. The other one's going to be the height of the object. So it kind of depends on whether it's the tree or the flagpole. So the height of the object over its shadow. And that way I could actually find any type of height. I could even find, somebody else's height if they were standing next to these images here. Well, from there, I'm going to go ahead and fill in what I've got. So I've got the height of an object. Okay, let's use the flagpole first. So I'm going to put that one on top. So I've got 8 over, and then its shadow was 6. So I'm using this object first. Its height over its shadow. Well, I'm going to set this equal to the height of the other object. Oh, I don't know that. That's my variable. That's what I'm searching for, h. And I've got the shadow height or length is 21. So now I could go ahead and solve this. And so we can go ahead and use that cross-multiplying tool, which allows us to multiply the numbers diagonal and solve for an unknown. So here we have 6h equals, so 6 times h right there, equals 8 times by 21. And then from there, all I have to do is multiply the 8 and the 21 and do a division problem. So let's see what I get there. I got a 168. So from that point, I could go ahead and do some division, divide by 6. And we'll see if 6 goes in there. And 6 will go in there. I know it does because 8 is one of the factors, and 2 goes into 8. 21 is a factor of 3, and 2 and 3 make 6. So 6 will go into this number. And we'll go ahead and write it out there. 6 into 168. So 6 goes into 16. We have 2 times. Makes 12, and we have a 4 left over. So 6 into 48 goes 8 times. So there it is. H equals 28. So the height of the tree was 28 feet. Well, the next one here, we've got a problem that talks about distance from Portland to Seaside is 75 miles. That's something important. Oh, here's the question. This is always important. What is the distance? What is the distance? I don't know what the distance is. Let's use a variable, d. How does that sound? D is our variable, and it's in inches. Okay, that might be important as well. Okay, What is the distance in inches between two towns on a map? Okay, so that means that we're going to end up using a scale factor, and that's what they have here. 1/4 inch is to 25 miles. So that's what we're going to do. We're going to set up a proportion, just like I did here. I did height of object over shadow, height of object over shadow. Same thing on this one. Inches per mile, and I'm going to set another one, inches per mile. So let's take a look at the scale factor, 1 1/4 inch. So I write 1 1/4 inch, and then I have over 25 miles, because this is an inch, this is miles, equals, and I do the same thing here. Okay, they're asking what is the distance in inches? In inches, we don't know that distance, that's the question. And so that goes on top, because inches goes on top. So I'll use D this time. And then the distance is 75 miles. The actual distance is 75 miles. So from there, we're just going to go ahead and cross multiply. Same thing we had done before. And so we'll cross multiply these numbers and see what we get. So when we do this, we've got 1 1/4 times by 75 equals 25 times by D. Well, let's go ahead and multiply those two numbers right now. So we can go ahead and do that. We've got 1 1/4. Well, we can do one of two things. You can either change it to decimals or fractions. So it's in a fraction form. Let's change it to keep it in the fraction form, I guess. 1 times by 4 plus 1 makes 5. So 5/4 times by 75, treat 75 as 75 over 1 equals 25D. So I do the math there. 5 times 5 makes 25. No cross canceling, so I have to multiply. 25, so I carry a 2. That makes 35, plus 2 makes 37 over 4. I'm going to leave it this way because I got to do a division problem. So I'm going to divide by 25. So that's next. So I show this by a little fraction bar here, or you can even use a division sign. So I'm dividing by 25. That's the same thing as dividing by 25. Like 25 over 1. Now when we do that, we actually multiply by the reciprocal. Now we keep the first fraction the same, 375 over 4, but we're multiplying by 1 over 25. Now as I do this, I think of quarters. See, 25 cents goes into $3.75. Think of that as like 375 pennies is $3.75. How many quarters make $3? Well, 4 quarters make $1. And so if I needed $3, that would be, so $3 would end up being 12 quarters. But I have 3 extra quarters and 75 cents, so plus 3 would give me 15. So that's what that changes to. So we just reduced that really fast by thinking of quarters as we did that. And so there's our number there. We've got 15. So D equals 15/4. So all we have to do is divide. See how many times 4 goes into 15. And it goes in there 3 times. That makes 12. 3's left over. So there it is, 3 3/4 inches. So that way we can understand the problem a little better. 3 3/4 inches. So we got our answer. So those are some of the problems on your homework tonight. Good luck on tomorrow's test.